Hello, hello. How is everyone
Hello.
doing?
So good.
Good. I was just counting how many days we have left. It's not many. Eight. Thanks for that face, Jessica. I appreciated that. Yeah, 8. That's what I said too. I was like, "Well, how much material we have? We got 8 days."
So I have a question.
I'm ready.
So I was looking at the oral exam time slots.
Yeah.
So is our last day going to be Wednesday, or we still attend class Thursday as well? Or are you just not doing oral exam Thursday?
On the 13th? Is that the date we're looking at?
No, I was looking at, because we were extended a week out, right?
Right.
So because I reserved for Wednesday the 19th. So
Yeah, I'm not doing Thursday the 20th.
okay, it's just making sure.
Yep. I was going to share my slides and then I don't see them. So that's a little troubling. So it is We Share Wednesday. What do you guys want to share while I'm getting these slides handled? Anyone have anything good, bad going on?
I can share.
I'm ready.
Well, this weekend I got bit by something. So yeah, I had to get that situated. And my family members got vaccinated this week, so it's nice.
Nice. And did you already?
I'm actually the only one that still needs to. Like everyone got it this week, and I'm like, oh crap, I need to make some time.
Yeah. So did you hear that you no longer need an appointment at the state-run sites? They say that they recommend them. Yeah, they recommend an appointment, but you don't have to have one. What else is going on, guys? Nothing.
So I work at the Learning Experience, which is like an early childhood school / daycare kind of thing. And a lot of daycares right now are hiring. There's kind of like, I'm sure you all know, like a lot of people need more hires and a lot of people are quitting. So daycares are in desperate need of teachers, as all schools are. But I'll put my school's information in the chat. But we really need some good people who want to teach.
Nice. That's awesome. Thanks, Karina. So yeah, basically, if you look at the calendar, what we have left is we have tomorrow, obviously, and today. We have all of next week, and then the following week, we only meet Monday, Tuesday, Wednesday, because remember, we were supposed to be done then, but we're not. And my son's graduation is in Omaha the next day, so I'll be gone on Thursday, May 13th. We will not have class that day. Okay, so Thursday, May 13th, we do not have class. So basically, our last day of class is the 12th, and then we're going to go into final, right? So you have your final appointments. I posted the final questions. I know you're like, we literally just finished our midterms and you haven't even graded them yet. I know, but I'm grading them. I promise, as soon as I can. It's just been crazy. Thanks, McKenna. And so you can start working on those questions. And I haven't published next week or the week after because I'm trying to balance out your assignments. I'm trying to get as much done as we can in class, so you have fewer outside assignments, so we make sure we cover everything we need. Okay, you still will have assignments, but so that's kind of what it looks like. And I have this reminder that keeps popping up on my iPad. Sorry, I can't update my iPad right now since I'm teaching, but I will after class. So if that comes up, I'm so sorry. All right, so does anybody have questions for me about final exam time slots or anything like that? All right. Bethel, are you eating a pancake?
No, it's an omelet.
Oh, nice.
Yeah.
Somebody in my last class said they got up early and made pancakes, so. Oh my gosh, Karina, isn't Eastmark far away? Like compared to Mesa Community College, let's put it in perspective.
Yeah, compared to MCC, I think it's maybe 25 minutes away, which is far, but it's like 5 minutes from my house. So if anyone lives in like the East Mesa area, it's good. There's like a lot of them though. I think there's one in Gilbert, one opened up on Dobson, I think. There's a lot of daycares that need teachers, so yeah.
Kelsey, what do you mean it wouldn't let you sign up?
So like I chose a time slot and I tried to reserve it and it said air cannot reserve.
Somebody else might have signed up for it. Which time slot were you trying to get?
I was trying the 19th at 10 and it wouldn't work. And I tried at 11:20 also and it wouldn't let me.
Maybe refresh Canvas and see if it will.
Okay.
Just refresh Canvas and see if it works. Because that time is open still. All right. So anything else? Are we good? Any questions? We all right so far? Are you excited? Because a lot of you are done after these next couple weeks, right? You have like 3 weeks at the most. Yeah, exciting. Okay, we're going to take the first part to kind of finish up our last 2 slides from yesterday, which are tree diagrams we've talked about now, plenty. We talked about them with probability, where we were doing multi-stage experiments, but we can also talk about them in general when we're trying to describe relationships between things. Here's one about desserts. So the top of our tree diagram is the least specific. So that's our most general category, so desserts. Then I have it broken down into cookies and ice cream. And then underneath cookies, I have oatmeal and chocolate chip. And then notice they have a line that joins them. So I could make oatmeal chocolate chip cookies, which are considered oatmeal cookies and considered chocolate chip cookies, and they're still considered cookies, and they're still dessert, right? Okay, on the other side, I have ice cream and I have vanilla and chocolate. Now, ice cream is not a cookie. Maybe I have ice cream cookies, but that's not a category yet on my tree diagram, right? So they are not connected by a line, but they are both part of dessert. Makes sense. We know how tree diagrams work. What I want you to do right now is think of a tree diagram using these words. So this vocabulary should look familiar from yesterday. Concave, convex, irregular, and regular. But then we know a triangle has 3 sides, a quadrilateral has 4, a pentagon has 5, a hexagon has 6. Heptagon is an interesting one. Sometimes some people call heptagon a septagon. They still mean 7 sides. So these are the same. One is a Latin prefix and one is a Greek prefix. That's the only difference. So you'll see in textbooks sometimes heptagon, sometimes septagon. Octagon is 8 sides, nonagon is 9 sides, decagon is 10 sides, and dodecagon is 12 sides. Okay? So I want you to work with a partner. You can use a Jamboard, a whiteboard, whatever you want. I want you to screenshot it when you're done. And think about, for me, the hard part would be trying to figure out where these things go, right? Where these things belong in my tree diagram. So you might have a couple ideas. Questions on what I want you to do? I'm not going to give you a whole lot of time, maybe like 6 minutes at the most. Everybody okay? Okay. Hold on one sec. Oh, I think it's Technology Wednesday day. Everybody's been having problems. Okay, so when you're done, make sure you've saved whatever it is, your screenshot or whatever, so you can share it with me when we come back, okay, and with the class. Everybody knows what they have to do? These are your words: irregular, regular, concave, convex, and then shapes, triangle up to dodecagon. Okay, go for it. Kelsey, did it work, by the way?
Yes, it did.
Okay, good.
So is it just a Venn diagram or both? Like a tree diagram?
A tree diagram, just a tree. Did I say a Venn? Sorry.
Okay, thank you.
Yep. All right, I know that was quick, right? And I know some rooms might have had questions, but I just want your ideas. Thanks, Karina, for putting it in the chat for me.
I would just like to say right off the bat, I do not like that because, thank you, Madison. Because all those shapes can be either convex, concave, regular, or irregular. So
Wait, are you positive?
except for a triangle, that can't be concave.
Okay, a triangle cannot be concave. Yes, do we all understand that? Okay,
But other
so
than that,
why didn't you like it, Hannah?
I'm angered.
Okay,
I just don't understand how we can put one of those things under another, except that regular polygons will always be convex.
So you can't have anything concave that is regular. Is that correct?
Yeah.
So that's kind of important, right?
So that's like the one, so that and then the fact that a triangle can't be concave are the only two like concrete relationships that we could find to potentially put in a diagram.
And well, definitely, what would you put at the top?
Yeah, so that's the issue.
we didn't know what to put at the top.
I can explain what I did because now hearing everybody else's insecurities, I feel like I might have done mine wrong because I did mine overly simplistic. I put polygons at the tops, and then I put shapes for one branch and terms and attributes for another branch, and then I put the corresponding terms under those. So a triangle is a shape, and irregular would be an attribute. But I don't have anything connecting between those two.
Okay, so polygons at the top. Did anyone want to go like this and say regular and irregular? Did anyone want to do this?
That's how I started it. I put regular and then irregular.
And then under regular, we could only have convex, right? We can't have concave. Do you agree? Am I really not sharing? That's stupid. Oh, that's because I got kicked out of the whole meeting with my iPad. So that's annoying. Hold on. My technology saved it for today. Saved it for your class today. Okay. So then I'm going to share in just a sec. So you could have polygon at the top, regular versus irregular, and you could have convex under regular, right? And then over under irregular, we can have both convex and concave, right? And then we could have all our shapes down here, triangle, quadrilateral, pentagon, hexagon, septagon, octagon, decagon, and dodecagon, right? What would you do with all those?
Well, you could put them under everything except with the exception of the triangle.
Yeah, they could go under all of these, right? So they could go all right here. And you could have pictures, right? And you could have a whole nother set on the other side with lines to these, right? And pictures. Yeah. So Hannah, I feel like, why were you hating it?
There's just so many lines there, but I do understand. I mean, the relationship. I just didn't know how to depict it conveniently.
Yeah, I don't think it is conveniently, but the good thing about it and the point of the activity and why it only lasted 5 minutes was that you realize that triangles cannot be concave, right? And no shapes can be concave and regular. Yeah, that was kind of the objective of that activity. Did we meet that objective? Yes, no, maybe.
Yes, objective met.
Okay, yay. Madison's like, I was all on board with Hannah, right? Did my iPad just get kicked out again? Can you still see my screen? Okay, good. I feel good. People are coming and going like mad because of technology issues. Might be me, might be you, I don't know. Bethel, question.
So since my at least for me, since I couldn't finish this diagram with my group, do I just send in my point, like my picture in the screenshot, or?
You're fine.
Okay.
You're fine. We just went over it, so you're all good. Okay. Okay. I'm going to share a whiteboard with you, and I want you guys to all write on the whiteboard. You can do that. You know that, right? I want you to all write on as many things as you can think of about triangles right now. First of all, can you see the whiteboard? Now, can you? Yes? No? Maybe?
Yeah.
Okay, good. So write all over it. You can type on it, whatever you want. Everything you can remember about triangles.
Wait, how do we write again on the whiteboard?
There should be a thing at the top that says annotate, or under more, it should say something like that, where it says I'm screen sharing. I don't know why mine looks weird to me, but there we go. Yeah, so Kelsey, just type in the chat. If you can't write on the whiteboard, just type in the chat everything you remember about triangle. 3 sides, 3 angles. Ooh, I see some word equilateral, isosceles spelled a little questionably. scaling 180 degrees, right angles. You guys like to spell isosceles, very interesting.
I looked it up. That's how it says it's spelled. ISOSCLES. CLES. Did I spell it wrong? Oh, CE. Okay.
Acute. All right, so you guys do know some things. Oh, I like that. Scaling is no equal sides. We could have a regular triangle. We definitely have convex triangle. If there's a right angle triangle, two angles are acute. Oh, I'm not sure what each side of 60 is. Do you mean each angle? That's in an equilateral triangle, right? All right, good. I'm going to save this for us so we have it. And I'm going to stop sharing with that. So you guys do know what triangles are, right? And you know some things about a triangle, which is good. We're going to do, we can classify triangles by their sides and by their angles. And we're going to go over some of that vocab today. So this is kind of what we talked about yesterday. Young children starting to learn about shapes are often accustomed to only see equilateral and isosceles triangles, and they struggle if they have a triangle that looks like this. Remember we were talking about when we only show students perfect shapes or shapes that look a certain way, when they get something else, they get confused. So make sure you show them all kinds of triangles. So we can classify triangles by their side length and their angle measure. How many of you have used Nearpod before? Anyone used Nearpod before? Okay, so we're going to do a Nearpod. I'm going to see how it works because I'm going to start a session right now and see what it does. Hold on, it's thinking. It might be too much for all of our internets right now. I'm going to put a link in the chat. And you should be able to click on it. And I'm guessing it'll ask you for your name. Is it doing anything when you click on it?
Once I put in my name, it sent me to the slides.
Oh, perfect. So now I can see Elena, Amanda, Bethel, Hannah, McKenna, Sarah, Sunita. Very nice. And Tyler. So, and you can do these in your classroom, right? Oh, good. Now I can see more. I see Sydney, Vanessa. I see 15 of you are in so far. And I control where you are in there as far as I know. Like you can't go to the next slide without me, as far as I know, but it's different on different things. So anyone still trying to get in? Okay, now I have 17 of you in. That might be all of us. How many do we have? 19. And we're missing, we have Maddie here. We still have Betty here, right? Betty was having internet issues. Okay, so now we have everybody. Good. So this is an activity that was pre-done and then I just modified it, just so you know. Your screen should change. Did you see your screen change? Nice. So triangles and pyramid, you can see this is from a textbook, right? That someone made. So this is what their textbook looks like. In this lesson, students will learn about triangles and pyramids and recognize different types of triangles. So I kept this slide on here so you could see this is the Common Core standards that it's meeting, 3G1, and then there's a couple in 4th grade as well as 5th grade. So this would span several grades and you could modify it however you choose. See what happens here. This just says connecting, please wait. Does yours say anything? Apparently I don't need this paper. We'll skip that. So here's a pre-assessment. Can you see names on there? What does your screen look like? Somebody show me your screen. Do you see questions? Good. Excellent. Good. So go ahead and answer the question on the screen. Let's guess what's the angle of this figure. This is a pre-assessment.
So after I answer the question, it doesn't let me go to like another screen. It just says
Yeah,
your answer has been submitted and edit answer.
What does it say? Your answer is what?
It just says your answer has been submitted and then it just says edit answer.
That's perfect. Just leave
That's
it. So I can see on my end all of your results. And I can share the results by doing this. Can you see the results now of that question? Yeah, so Sunita can see, and right now we have some internet, right? Internet. So if you can't see the results, it's okay. So, and then I'm going to go to the next question. So the answer to that one was 35 degrees. Although I know a lot of you put 65 degrees, it's okay. I feel like it was questionable. Here's the next one. Try this one. It's okay, Maddie, if it freezes, just play along. I will read you what's happening. So, and I can share my screen in a minute, so it might help you see what's happening. All right. So that one we did much better on, right? That one we all got. That one was a little easier, I thought. Okay, how about this one? Try this one. All right. Again, that one should be 10 degrees. That's a very small angle. So you can imagine that if you're in your classroom and you have iPads accessible to your students, You could have all your students on the iPads and they could be working on this as you walk around, and you can see a graph on my end of each student and how they're answering, right? So last one, I think this is the last one. We're almost done with this, Maddie, by the way, if yours is still frozen. So what you guys are doing right now is just a pre-assessment, right? So this would, maybe you haven't even discussed this with them. Maybe you're reviewing, but this is a nice way for them to see. And then I can see how each student did as well. Okay, so this is what I want to do now is we're going to talk, we already know that a polygon is any closed figure or shape made up of all straight lines. A triangle is a polygon with 3 sides and 3 angles. This is where you could use your chart, your triangle chart, or you could make one. It's an assignment on Canvas, right? And you could write down equilateral, isosceles, scaling, and you could write down each one of these definitions on your chart and draw a picture. If you're drawing a picture, please use a straight edge. You guys can see those on the screen, right? Except for Maddie can't. So I'm going to show Maddie. Hold on. So you can have Zoom in a different window, right? I'm going to share so Maddie can see. Maddie, can you see that now? No, I can't see Maddie. So. Is that better, Maddie? Okay.
Yes, I can see it.
So I'm just going to give you a few minutes to write down the stuff you need. And if you want to draw them perfectly later, that's totally fine, because I'm pretty sure this is an assignment you have to turn in. The chart. Now, the definition for isosceles can vary depending on which textbook you're reading. Sometimes a textbook will say, an isosceles triangle has exactly 2 sides that are the same length. Sometimes your textbook will say at least 2 sides that are the same length. Do you see how those definitions would be different? Because if you say at least 2 sides are the same length, then all isosceles triangles have this criteria. All equilateral triangles would meet that criteria, that all equilateral triangles are isosceles because they do have at least 2 sides that are the same length. Okay. So, but depending on how you define it, I define it as at least 2 sides, the same length. So all equilateral triangles are also isosceles. Everybody okay? Does everybody have the info down? You can perfect it later, right? But you have that equilateral means all sides the same length. Isosceles means at least 2 sides of the same length, and scaling means all sides are different lengths. We can also describe angles of triangles. Okay, and so when we're classifying triangles by their angles, we would say acute if all 3 angles are less than 90 degrees. We will say obtuse, it's an obtuse triangle if 1 angle is more than 90 degrees. So do you see how those 2 have different attributes, right? One says all 3 have to be less than 90 degrees, and the other one says 1 angle is more than 90 degrees. And then a right triangle has 1 angle that's measure is 90 degrees. So when we describe triangles, we can describe them by 2 words, their sides and their angles. I'm just going to give you a little bit more time to write all that down. And I highly recommend if you do a Nearpod with your students, you make sure that it's interactive. If you're going to do something like this part where you want them to write, have that foldable ready for them, right? Or that chart ready for them so they can draw it and fill it out as they're doing it. And then they would glue that in their notebooks. Everybody okay with this page? All right. So now I know it's so sad, Maddie, you won't be able to see it. And Kelsey, I don't think you can do it on a Chromebook. So you can see my screen because I'm showing everybody's screen and I have your names hidden, which is really nice. So this is a matching activity and it says, okay, draw a line from the term to its definition. You should be able to change the color of your pencil. Kids love to do that. So if you want to experiment with that, you can. And on my end, I can see how every student is doing, right? And I can see if I'm awaiting their drawing or if they're finished. Like this student is finished and I can see if it's correct or not. So, and yeah, so somebody submitted it. So I can see once it's submitted, once it's in progress. So it's kind of a cool thing, and you can make these whatever you want, right? You could have students match terms with definitions. So do you see how this isn't necessarily just math related, right? You could do this in any subject you want. We're just doing it in a math environment. By the way, kids love Nearpod. Kids love to do anything on the iPads, right? Oh, I'd like somebody figured out how to change the colors. You can tell us how you changed them if you want. Does everybody figure out how to change their color if they want? So I like Nearpod because it's very customizable. The thing I do not like about Nearpod is unless your school has a site license, you can't do this asynchronously. So you can't let students work at their own pace. You have to do everybody at the same time, which is how we're doing it now. Is anyone stuck? I don't want to move on if you're still doing it because I see a couple people haven't drawn yet, but I know that some people can't. This works best in a classroom where you have a cart of iPads, right, for your whole class, which a lot of schools have. Anybody need me to wait? It also records this for me later to look at it on my dashboard. All right. And then it goes over the solution. So usually once I show this screen, everybody wants to go back to the other screen and change all their colors. So just be prepared for that with kids when you do something like this. But it's nice because then they can relate these words to the definitions now that they see them all in one place. And that's it. So the reason I wanted you to see this was just so you could see how you can do some interactive things, even if you are face-to-face with students, right? This is a great technology when you're not face-to-face, but it's really good when you are face-to-face. Kids love Nearpod. This was the chart that you were filling out. Hopefully that's an assignment on Canvas. Just make sure if you did it kind of halfway right now, make sure you use straight sides when you do your problem. I'm going to skip this. I'm just going to talk about it because I want to make sure we get through the rest. One thing we could do if we were face to face, I could give you a piece of paper with these triangles on it, and I could make sure that your groups all have protractors and that we could measure each one of these angles, interior angles, and you could split it up. Like, let's say I put them in groups of 4, and I say, okay, SA, you're going to do this one. Tyler, you're going to do this one. Amanda, you're going to do this one. And Sunita, you're going to do this one, right, in the group. And then they discuss what they might notice about the interior angles of the triangle using this as their tool, okay? You guys already know a lot of this, so I don't have to spend time on that. But is that really a proof? Do you think the students would end up with 180 degrees on all their triangles if they measured them with a protractor? Do you think they would end up with that? What do you guys think? Yes, no, maybe?
Probably not, but they should be close enough to see that it's probably realistic in real life.
Absolutely, Hannah. They probably won't be right on 180, but they might get the idea and they might go, ooh, maybe it's always that. But it's not really a formal geometry proof that the sum of the interior angles of a triangle are 180 degrees, right? This is what you needed your piece of paper, your straight edge, and a pair of scissors for. Does everybody have it? Everybody have a piece of paper, a straight edge, and a pair of scissors? Yeah? I'm gonna get my paper. All right, so here's my papers. Everybody have a piece of paper, a straight edge, and a pair of scissors. This is your job. Draw a triangle, okay? Draw a triangle on this paper and make it big, right? I don't want a triangle that's like this much of the paper. That's all you're doing with this piece of paper is drawing a triangle. That's all you're doing. So draw a triangle, any triangle you want. Draw your triangle. After you draw your triangle, I want you to classify that triangle by its sides and its angles. So right in the middle of the triangle, right? What type of triangle it is. It doesn't have to be the whole piece, but it should be a nice big triangle, okay? My scissors seem to have walked off. I'm gonna go grab my scissors. After you draw your triangle, so here's, I drew mine. Now I'm gonna classify it by its sides and its angles, and I'm gonna cut out the triangle. So that's what I want you doing right now. Okay, so you drew your triangle, you cut it out, and you classified it by its sides and its angles. So my triangle is an obtuse scalene triangle. That's what I made. Okay, so let me know when you're done with yours. Okay, is everybody done? 30 more seconds? Does anyone need more seconds? Okay, everybody's done. Everybody hold up your triangle like this so we can all see it. Very nice. Do you see how we all have different triangles, right? Like none of us have the same triangle. We just drew them. I know with you guys with your cameras off, I can't see your triangle, but I'm assuming you're holding them up. Everybody good? Okay, you can put your triangle down for a minute. Does everybody have 2 words written in their triangle? Yeah, okay. I want you to hold up your triangle. You can type it in the chat if you can't turn on your video. If you made an acute triangle. So if you made an acute triangle, hold your triangle up. If you made an acute triangle. Okay, I see Elena's, Amanda's, Madison's, Andrea's, Hannah's. Do we all agree, the ones that we can see, the ones that are holding them up, are they all acute? Excellent. Okay, if you made an obtuse triangle, hold it up. If you made an obtuse triangle, hold it up. Just me, Tyler, and Bethel were the only ones who made acute triangle. Okay, I mean obtuse, sorry. We made obtuse triangles. Okay, good, put those down. Did anyone make a right triangle? Hold up your triangle if you made a right triangle. Do we agree, everyone who's holding them up, their triangles are right triangles? Excellent. Okay, good. Now, who made a scalene triangle? Who made a scalene triangle? Hold yours up if you made a scalene triangle. So funny, did you notice me, Bethel, and Tyler made obtuse and scalene triangles? Yeah. McKenna made a scalene triangle. Who made an isosceles triangle? Raise your triangle up if you made an isosceles triangle. Ah, about 3 of you or 4 of you made an isosceles triangle. Excellent. Now, Brianna, is your triangle isosceles? Hold it up so we can see what it really is. So it's right. It's a right triangle, but how would you classify yours by sides? How many sides are the same length? Did you guys see Brianna? What word would you use to classify Brianna's? I think she's
Scalene.
having mic issues. Yeah, yeah. Brianna said hers would be scalene. Excellent. Scalene, no sides the same. If you have a scalene triangle, hold it up. If you have a scalene triangle, hold it up. Oh, mine was too. Sorry, I lost that. Mine was scalene. Okay. And then we did isosceles. Did anyone make an equilateral triangle? Anyone else make an equilateral triangle? Is it really equilateral? Like you promise it's equilateral? Like you used some measurement tool to verify that it was equilateral? really hard to freehand an equilateral triangle, let me tell you. I'm not saying I don't believe you. I'm just saying that it's very rare that that would happen without using a ruler, right? And actually measuring all three of those, right? So, okay, good. Now, I could ask who has a right isosceles triangle, right? Did anyone make a right isosceles triangle? Anyone? Oh, a right isosceles triangle. Sarah did. Do you see Sarah? I saw a right scalene triangle from McKenna, right? Is it possible to have a right equilateral triangle? Madison's like, I think that's a no. No, it can't be right and equilateral. So some of these combinations don't work, right? Yeah. So you have to think it through. This is a great activity to do with kids after you've done some sort of classifying, right, by their sides and their angles, and make sure, and you can have kids to move to parts of the room with their triangles, right? Anyone who has an obtuse triangle go over here, anyone who has an acute triangle over here, anyone who has a right triangle over here, and then you switch it up by the sides. And you have kids hold, or if you don't want them to move out of their seats because they're a train wreck when they do it, you have them sit in their seats and hold them up. Okay, so now we're gonna do the second part of this activity. Please, please, please listen carefully to my directions, okay? On your triangle, before you cut it up, can you label your angles A, B, and C? Label them A, B, and C. I don't care which one's which, as long as they're all three labeled, A, B, and C. Yeah, so label them A, B, and C. Very nice. Now, this is the part that teachers don't like. Move your scissors far away from you. Yes? I don't want you picking up your scissors. Okay, for this part. Don't pick up your scissors. It's called rip it off, this activity. I want you to tear it, not nicely. I want it like jaggedy edge. Do you see my jaggedy edge? Do you see that? Yeah. So there's my angle, there's my jaggedy edge. I want you to rip off these three. And some of you are secretly crying inside. You're like, I don't want to rip it. I want to cut it. I want you to rip it. Okay, so you can see the angle. Okay, so rip all those off. See, I ripped them all off. And then I want you to arrange them in front of you where all the angles are together. And I'll put it on a whiteboard so you can see it or something. So arrange them and tell me if you notice something. I hope you do. Oh, nice. Some people are putting it in the chat. Some of you are like, I don't even understand what you're trying to get me to do. It's okay. I don't want to give it away in the picture. I'll show it to you in just a sec. That's what mine looks like. Put all the angles together. Yeah, put all the angles together. Anyone having trouble with theirs? So it should look like that in that picture that I'm showing you. Am I still sharing my screen, I hope? Okay, good. Everybody got it? Did everybody do it? Yeah? Okay, now this shows you that the sum of the interior angles of a triangle are what? Yeah, 180 degrees. How do I know? Because they form a straight angle. And it didn't matter which kind of triangle I started with, right? I had an obtuse triangle. McKenna had a right triangle, I think. Sunita had an acute triangle, I think, right? So we all had different triangles and it didn't matter. You still got a straight angle, yes? Everybody got a straight angle. Now, is this a formal proof that the sum of the interior angles of any triangle are 180 degrees? No, but it's a real good one, right? It's a really good one. Has anyone done this activity before? Anyone done this before? Did you know that's why it's 180 degrees? Like, did you ever think about it? like ripping those angles apart and putting them on a straight line. No, you guys knew 180 degrees in your head because someone told you that, right? But you didn't have real connection to it. This activity gives students some tangible connection to this idea. Yeah, it's one of my favorite activities and it's very, very long lasting. Glad you like it, Karina. I'm telling you, students will remember it because they will get lots of numbers thrown at them, right? They know right angles are 90 degrees. They know a full circle is 360 degrees. They know something is 180 degrees. But as soon as they do a hands-on activity like this, they will remember it. I've had students, when I taught in an actual classroom, like with young students, they were taking a test. And this, kids don't like to take tests. And this kid was asking me a question. This kid goes, I don't know how to find the missing angle, right? The question was like this. It had a triangle, and it said like 67 degrees, 84 degrees, and then it said X degrees, like this, right? On their paper. That was the problem. And they were supposed to find the measure of the angle X. And the student goes, I don't remember what the total is. I don't remember what it's supposed to be. And they go, I know you can't tell me. And I said, I can't tell you, but I am going to remind you. Do you remember an activity where we ripped off the corners of a triangle? And he goes, oh! And he goes, thanks. And I walked away. And that was the reminder that he needed. And I've had kids talk me through that idea in other activities when they're not taking a test and they go, oh, that's why you had us rip that stuff apart, right? Yeah. So the reason it's important, first of all, that they label the angles before they do it and that they don't cut them. Can you imagine if you cut it, do you see how now you have another triangle? And kids can't remember which was the angle from the triangle? It's disastrous if you do that. So be very careful. Now, in my notebook, like when I do this normally with students, I would put this triangle and my little taped thing all on the same page. And I would write myself a note of how to do this activity so I wouldn't forget it, right, for later. So I really, really like this activity and I think it's very meaningful. Okay. Any questions on what we did? Oops, sorry, didn't mean to do that. So I think this is a pretty convincing way to show students that it's 180 degrees. I'm not saying it's a mathematical proof, but it's still pretty convincing. Do you agree? I think Karina is the only one who likes my activity. Thanks, Karina. I appreciate you. Everybody else is just sitting here like, are we done yet? Takes too long. Huh, Brianna laughed. Okay. You guys don't understand how hard it is to teach like this, you know, like it's hard. Okay. So, you know, which method do you think does a better job at convincing us that the sum of the interior angle measures of a triangle is 180 degrees? How do you know this method will work with every triangle? Can we try it out on every one? And then does this method actually prove it? We've kind of talked about this, but I want you to think about this. What we did here, did a kid need to know how to use a protractor to do this activity? No. To do this first activity here, does a kid need to know how to use a protractor for that part? Yeah, for this part, when they measure the angles, they need a protractor. So that's why it's nice because it depends on what skill you're teaching, right? On the day when you want to do protractor practice, do it this way. On a day where you just want to see them the big picture, do it the other way. I like doing both, but in a pinch, I will skip this protractor part and I will do the rip it off part because I'll do protractor practice on a different day. Okay. Tyler, I know you, when I do this face to face with students, especially teachers, they literally do not want to rip their triangle. They're like, well, I don't want to rip it. I'm like, it's okay. You know, the triangle is helping us, right? So it's like science. It's like donating to science, right? It's okay. The triangle is going for good use. And teachers really want to use those scissors. They really want to cut those corners, let me tell you. And then the whole thing is ruined. I've had people do this in class. By the way, just as a little refresher, in case you need this, because I know I had a worksheet on it, and I know you have an activity on it, but you also have a video that's due tonight, right? Your Flipgrid video for protractors. So when I'm going to measure an angle, sometimes what's hard when you measure a triangle or any angle, these sides aren't long enough. And so you need to extend the sides. I was using a straight edge, just my iPad doesn't like it. Okay. So I'm going to extend this one as well. And I'm doing it straight, believe it or not. Okay. So then when you use your protractor, you put this part right down on that center piece and you line it up. I'm going to unplug my iPad so you can see what I'm doing. I know it's really bright. Hold on, let me see if I can turn my brightness down. But this will help you make sure you see. I thought I could just turn my brightness down with one button. Is that not a thing?
You have to use the command center. You can turn
Okay.
it there.
That seems annoying. Seems like I should be able to do it faster. All right, maybe you can see it better now. Should have just done it on a piece of paper. Okay, so you put the circle on the vertex. I'm going to go the wrong way. You line up that bottom line. And then do you see why I extended the line? Because now I can see it on the protractor. Okay, now I can see it. So if you're measuring something, that might be one of your steps you have to do is extend that line. And then since I know this is an acute angle, I can measure that. And I would say it is, let's say, like 54 degrees is this angle. So just so you know, that's how you use a protractor. But I do think, does anyone have a fancy protractor with a little arm right here? Does anybody have one of those? Maddie, do you have one of those? Yeah, so the ones with the little arms on them are really nice. You can move it, right? And it helps you read it better. But most of us have just these cheap ones in class, right? That you have a whole class set. Madison, do you have it? Hold it up so we can see it. Do you see her fancy little arm on there? Yeah, so it's like a little dial. That's very nice. Okay. So you have some triangle. We don't have triangle homework yet, so don't worry about your triangle homework yet. But you know, a triangle can have exactly two acute angles. Do you think that's true or false? A triangle can have an obtuse and a right angle. You think that's possible? Can a triangle have an obtuse angle and a right angle? Yeah, no way, right? Because, okay, if it was right, it's 90 degrees. And if it's obtuse, it's at least 91 degrees. So if I add those two up, I'm going to get bigger than 180 degrees, so it's not going to work, right? A triangle can be scalene and right. We saw that. Can a triangle be equilateral and obtuse? Why not?
Well, then the interior angles would be greater than 180 degrees.
Yeah, well, obtuse and an equilateral would mean they're all the same, right? So that's not going to happen. Do you agree that all equilateral triangles are acute? Do you agree with that? All equilateral triangles are acute? Yeah, have to be, right? Have to be. Excellent. And then can a triangle be isosceles and right? I feel like someone made one of those. Was it you, McKenna? Yeah. So yeah. And then the first one we didn't really, can it have exactly two acute angles? Yeah, because it could be right and isosceles, just like the last one. So part A and part E kind of go together. Look at these 5th grade comments. So 2 5th graders are trying to classify this triangle by angle measure. Luis says, I think it's an obtuse triangle because the measure of angle ABC is 126, which is greater than 90 degrees. So it's an obtuse triangle. And Mark says, but there are 2 acute angles. The measure of angle BAC is 30 degrees and the measure of angle ACB is 24 degrees. So I think it's an acute triangle. What do you think about each student's logic here? Who is right? You guys are like crickets today.
Lewis is correct.
Yeah, what's wrong with Mark? Mark is correct with part of it, right? Mark has part of it right. Because it's true that there are 2 acute angles. What is Mark confusing?
I think he just sees that there's acute angles and then kind of just forgets the obtuse angle.
Yeah, well, do you think that it's confusing that we have the same word to describe an angle and a triangle, right? So we can say there's an acute angle in this triangle, but it's not an acute triangle. So using that word, it's important how we're describing the whole thing, because the definition, what Luis needs to tell him is, to be an acute triangle, all 3 angles have to be less than 90 degrees, right? And since we don't have all 3 angles less than 90 degrees, this is not considered an acute triangle, even though it has 2 acute angles. The definition of an obtuse triangle is 1 angle greater than 90 degrees. Therefore, since I have an angle that measures 126 degrees, this is an obtuse triangle. But can you see how students could get confused by that language? Yeah, very easily. Okay. How many of you have heard of the triangle inequality theorem? Okay, we're going to investigate it. You don't have an assignment on it yet because you had so many other assignments. I didn't want to bombard you with that. So we'll do that next week probably. So, but the triangle inequality theorem, think about what that might mean. Some of you will recognize it, some of you will not. Okay, you still have all your assignments to do. I know, it's amazing. It's 1:15. Okay, so I'm going to put the exit chat in the ticket. That's what I was going to say. I'm going to put the exit ticket in the chat for you. And then tomorrow we're going to discuss some quadrilaterals, and then we will, I'm going to release the next 2 weeks. If you weren't here in the beginning, I'm going to release the next 2 weeks as soon as I can. So then I know some of you are trying to wrap up your last things, right, with classes, and you don't want too much at one time. So I'll make sure, especially the more assignments, so you could work ahead on some of those assignments and get ready for your final. Okay, any questions for me? Concerns, anything like that? Don't forget to sign up for your final, but make sure it's when you can actually go. And if you have any problems, let me know on that.
So I have a quick question. I don't know if I didn't hear it, but when we were doing the Nearpod, the table for the triangles, I can't seem to find it unless there wasn't one.
I think, hold on one second. I thought it was an assignment on Canvas, but I may have dreamt that.
Yeah, I've been looking at modules. Okay, so I'm not the only one who can find it then.
Okay, and then otherwise, I know that it's in your, hold on one sec. I'm trying to do too many things at one time. I know that it is in your OneNote. Let me show you right over here. I'm pretty sure it's here. Oh, maybe I didn't. Oh, I know why it's not there. It's because we're not really on triangles yet. So, but I'll put it in OneNote right here for you.
Okay, because I
And
was
it's
also
okay
looking
if you
at
just-
OneNote.
Yeah, I'll put it in OneNote right here, but it's okay. It would have been an assignment on Canvas, but I felt like I was just giving you guys too many things. So I'll put it in there right now.
So is this not an assignment then?
Yeah, I think it's supposed to be. What I'll do is it will be an assignment.
Okay.
Okay. I'm trying to see what's going on with your exit.
I thought I did see it as an assignment.
I thought I did too, but maybe I dreamt it. So I will check it out for you. So the exit ticket might be a little tricky, right? Don't get tricked by the exit ticket. Maybe my answer's wrong. I don't know.
Roxanne, I have a question on that because when you said to find X on number 4, it doesn't look like it marked me wrong, but that doesn't look like a less than 90-degree angle. It looks bigger than 90 degrees.
It is.
Mm-hmm.
Yeah.
Yeah, you put the correct answer as what would be the interior. Yeah.
The correct answer is wrong. Is that what you're saying?
Yeah.
I think so, yeah.
Okay. Hold on one sec. Yeah, I put the interior angle instead of the exterior angle. So hold on, let me change it. So it should be what, 109?
Yep.
Mhm.
Perfect. Sorry about that. See what happens when you stay up too late. So there you go.
And then Roxanne, one more quick question. Since my protract, because you know it has the fancy dancy little hand, when I do make my video, do I just make it based off of like, oh, if you have this, like you can just go up to the angle, but if not, you can extend it? Do I like give both options in my video?
Whatever you want. You
Okay.
can do it. You can do it like your, your protractor if that's the easiest.
Okay. Sounds good. Thank you.
And you can say if you don't have the fancy little arm, you would have to extend it, but you don't have to show that.
Thank you.
Yep.
So the assignment that Bethel was asking about, it's the polygon table. It is listed as an assignment for Friday.
Yeah, but she was asking about the triangle table.
Oh,
That
okay.
was-
Okay, never mind. I
yeah,
thought you guys were talking about the table.
No, that was in my slides right here, this triangle table right here, this one.
Oh, okay. No wonder. I was like, I thought I did see that, but never mind.
I think I did the same thing as you, Vanessa. So, yep. All right, any other questions?